Page of Test B. So first, what is the total energy at position 4? Well, what we need to do here is add up the kinetic energy at position 4 and the potential energy at position 4 to get the total energy. These answers are coming from your answers to kinetic energy at position 4, so that's the answer to number 5 right here, and gravitational potential energy at position 4. The answer, adding up these answers here and here. And that gives us our total energy at position 4. Next, what if the roller coaster car comes to a stop at that first hill, what would its kinetic energy be there? Well, 0. If it's not moving, it's 0. So I was really looking for showing the work that it's 1/2 times mass times velocity squared, like here, where they're showing that work. But this student just explained that if it's not moving, there's no kinetic energy, and I felt that that was just as well explained. Now right here, this is showing 0 times 0. The mass would still be 35,000 kilograms, just times 0 squared, and 0 times anything is always going to be 0, no matter how many other things we decide to multiply. Now this student did a kinetic energy minus potential energy, which I'm kind of, I guess I can see that the, our total energy should be the same as it was here, and then we're subtracting all of the potential energy, which would be the same there. So I guess I can kind of see where this student is coming from, so I might go back and give that student some points back. That's a tricky response. But really what I'm looking for here is just that it's, no motion, so no energy. Then we have it should be, when we talk about the mechanical energy, if it's conserved and we're pretending that there's no friction here, so no thermal energy gets generated, then what must be the gravitational potential energy at that position 1? So it should be the same as our total. Our total energy is equal to our kinetic energy plus our gravitational potential energy, and this student is showing there is no kinetic energy when we're at position 1. Because at position 1, right here, we're saying that that roller coaster is at rest at the top of this hill. And so if there's no kinetic energy, then the total energy has to just be potential. And so it would have to match the answer that we have for our total energy right up here. It would have to be the exact same value, which they've written in. And then the last thing was this bonus question, which is solving for the height. And so this one was on the right track. What we're looking for here to be able to solve for that height is basically your potential energy divided by the mass and your acceleration. So our answer really should be in meters, not joules, if we're talking about a height. And not a whole lot of people attempted that one, but this one actually is pretty close. Well, actually, this one is perfect. So this is the total energy, and then they divided it by the mass times the gravity, which, of course, mass times gravity, that's the weight, and that's the answer that we got when we very first figured out what that weight was, and we did mg. They actually did that, and that is the correct answer. There is about 44 meters, 43.9 meters is the correct answer to that. So that's extra credit right here. As long as you at least tried the extra credit, I gave you a point towards it. But yeah, that is the end of this test.